Hello. Okay, this is the video for 6.7. This is going to be day 1. If you wouldn't mind calling it that, day 1. The second one clearly says day 2. This one's kind of meaty. Okay, so that will be the next video, but this is day 1. So to compute compound interest quickly, you can use a compound interest table which shows the amount of $1 for many interest rates and interest periods. So to use the table, you must know the total number of interest periods, okay, and the interest rate per period. All right, so the new principal is going to be the principal times the amount of $1 from page number 4. Now I'm going to tear it out of a different one. Yours, I might have Xerox. I probably goofed on this. I may have to make you an extra table so that you're not constantly flipping. I'm going to make people kind of sick. But let's just talk about that. So this is an old one. So this is the interest rate per period on $1. Okay, so I'll kind of talk about this as we go, but I won't have to keep flipping the page. All right, and then similar to the past sections, we are doing the compound interest is the new principal minus the principal. So use the compound interest table to solve. Round answer to the nearest cent. Okay, I'll just tear this off so it's kind of nearby. And okay, so I'll show that in a second. Okay, so let's talk about this. The principal is the original amount of money. Okay, so I'm going to number that number 1. The annual interest rate, you still have to convert to a percent, to a decimal, as we always have. So that's going to be 2 places to the left. So let me call that column 2. The interest rates periods per year. So this means it's compounded quarterly, semi-annually, quarterly, semi-annually. If you saw a 12 in there, it'd be monthly. Okay, so this is column 2 divided by column 3. So this is what I'm going to call column 4. But you would take column 2, the annual interest rate, divided by that. So we did that in this first lesson with compound interest, but now it's just kind of using the table instead. Times the total time. Okay? So remember, time is always in years. So if it said 1.5 or if it said 18 months, that is 1.5 years. Total number of interest periods. Okay, so you're going to take the number of years or time times the interest periods per year. So it's going to be column 3 times column 5. Okay, so I'm calling this column 6. Okay, but this is what you're doing. This is, here I'm doing 2 divided by 3. Here you're doing 3 times 5. So don't try to memorize it. Try to think about what it is that this is saying. Okay, so this is column 7. This means we're going to use column 4 and column 6 and the table, which I'll explain in a minute. Okay, and then column 8, we're going to take the principal times all of that in 7. So this is going to be column 1 times column 7. Okay, so let's begin. So the annual interest rate is 5.5, and it's got 4 interest rates per year. So I'm going to do 5.5 divided by 4. I would put that as a fraction bar, but I don't know, it's not very big. All right, so 5.5 divided by 4 is 1.375. For now, I'm going to put it right here, but then on this next one, I'll have to write a little bit smaller. So now I'm going to take the total number of interest periods. So because there's 4 per year, and this is 2 years, this is going to be 8 because that's 4 times 2. So think about that just intuitively. 4 interest periods per year, total time of 2 years. Okay, so here's where we get into our table. Alrighty, so the table, we have 5.5%, 1.375, so that's this guy, times 8. So that is going to be 1.11544. So you can circle it just like I did. I don't have a highlighter here. I'm going to use this. This is that first one. So that is what's going here. I'm going to put it above again, 1.1544. And now this is sort of in totality that you're doing that. So amount of $1. So it's making $1.1544 10,000 cents on the dollar. So that's where I'm going to take that amount from the table, 1.1544 times 3,750, which is 43.29. 1 times 7, 3,000 times I don't know. Okay. Okay, so sorry, look at what I did. So this didn't compute, like that was a lot of interest made on it, and it's not going to make quite that much. So it's 1.115. So I don't know if I wrote it wrong here. Yeah, I didn't put an extra one here from that table. So 1.11544. So it just kind of seemed a bit off. Now, you're not going to be able to know that probably for a little bit, so be really careful. Times 3750. So this is just kind of a nice way to get my new answer of $4,182.90. So otherwise, you'd have to multiply, divide, multiply, and then add to the principal. So this kind of gets it all together at once. All right, I'll go a little bit faster. So, obviously, I've got my 2.5 divided by interest periods per year. So that's going to be divided by 2, which is 1.25. I mean, I'm kind of doing that off to the side here, but that's where that comes from. And times 3 years. Okay, so it's 2 interest periods per year times 3 years. Okay. So I'm going to use column 4 and column 6. So I'm going to do 1.25, and then I'm going to go down the column to 6. So I'm going to go 1.25 down the column to 6. So that is going to be the amount of dollar during the interest rate per period. So it's just a chart that's going to, and then I'm going to make sure that I write it correctly, 1.07738. And that is coming from this column of 1.25%. So this is percent. And then this is going to be the interest period. So this is 6 interest periods at 1.25%. Okay, so then what I'm going to do for the last column is just multiply that. 1.07738 times $4,000 is 4309.52. So this is converting this decimal in the table sort of for you. Okay, so I'm going to start to speed up a little bit. Column 2 divided by column 3. So maybe this chart, you just are going to kind of do this. 2.75 divided by 2. 3% divided by 2. 5% divided by 4. 5% divided by 2. And 3% divided by 2. Okay. So 6 divided by 4 gives us 1.5, and so on. This gives me 2.75 divided by 2, gives me 1.375. All right, 1.5 again. You could probably do that one in your head, 1.25. Now imagine you've got 5 quarters, so that's going to get compounded 1.25 times. 2.5, 1.5. Okay, now this is going to be the number of years times the, I think I have red in here. Times the number of interest periods. I'm in my math office, so not the best spot, but this total time is the number of interest periods times the total time. So hopefully that kind of makes sense. I think it's a little bit easier than kind of doing it step by step. So 4 times 1 is 4. 2 times 4 is 8. 2 times 2 is 4. 4 times 3 is 12. 2 times 1, 2 times 5. Okay, so then the amount on the dollar for this chart is you're going to use like 1.5. So I'm going to use columns 4 and 6. So I'm going to use this column, so these values that I just got, and the total number. So this is the percent going across. So let's do the next one. 1.5% and 4 interest rate. So go over to 1.5% down to 4. So this is 1.06136. 1.06136. Be really careful so that you don't miss it, because if you miss it, then it's wrong. So you're going to do all that work for naught. Okay. This video is going to be long as it is, otherwise I would pause, but you feel free to pause at any point and make sure you can do this. I'm using a thinner pen, but that one doesn't work. These are pretty old. Ugh. Okay, let's go back to my markers. My markers are just a little bit fat. That's why it's hard to fit it all on the page. All right, so let me do this next one with you. 1.5, I'm going to go along the top, and I'm going to go down to 4 years. 1.5 down to 4 is the same. So we've already kind of had that one. 1.06136. Then we have 1.25, and then we have to go all the way down to 12. So 1.25 all the way down to 12. 1.16075. 1.16075. What I think I'll do tomorrow is hand out its own sheet. So I'm going to go to 1.5 down to 10 years. So that is 1.16054. And then this last one, we are going to multiply the amount times the column. So it's sort of the grand big answer. So there's a lot. It's a lot. We're getting a little bit tougher. So I'm just going to cover up and just show that. So I have 3,500 times 1.06136. So that is going to give me 3714.76. I'll try to write small. Then I have 2750 times 1.11544 for 3067.46. 3250 times 1.06136. 3449.42. All right, so do that one, this one, and that one. And you should have gotten 1683.09, 5620, whoopsies, 71, and 4177.94. This just went out on mine. Okay. All right, if that went out on yours, there you go. All right, so hopefully I'm going to start to go a little bit quicker, but keep that in mind. Maybe take a screenshot right now, and we'll get cranking. Okay, so Standard Bank and Trust pays 6% compounded quarterly on regular savings accounts. Carol Butler deposited $2,500 for 2 years. She made no other deposits or withdrawals. How much interest did she earn during the 2 years? So let's talk about some of these terms. Quarterly means, I'm going to use orange. Quarterly is 4 periods in the fiscal year. Fiscal is anything with money. So she deposited $2,500, so there's 4 interests per year. Total number of interests then is 4 times 2, because she had it for 2 years, so that's 8. So then I'm going to use that. The new principal is 2,500 times, and then I'm going to do the 6. So here's the 6% divided by the 4, so that's 1.5%. So I'm going to use my chart, 1.5% for the 8 compoundings is 1.14339. Nope, I lied. Wait. 1.5 and 8. Am I going down the right? Sorry about that. 1.58 is 1.12649. So again, you go 1.5. I don't want to highlight this too much. Maybe I'll use a pencil so I can erase it. But you're going 1.5% first and then down to the 8 years. Alrighty, so that is what is getting 1.12649. Well, no, I'm going to erase that because I really want it to fit. 1.12649. If I ever rewrite these, it probably won't happen, but oopsies, I keep on missing these. So 28, 16, 23, watch your rounding. All right, now if I'm just looking for the compound interest, now this is in totality, like, oh, how much interest did I earn? Now I have to subtract that amount from the original 2,500. So 28, 16, 23 minus 2,500 means that my investment, clear, make this a little bit lighter. Nope, that's making it darker. There you go. Is 2816.23 less 2,500. So your oh, what did that do? I was under a list. 2816.23 less 2,500. 316.23. Okay. All right, so we kind of have a little bit more. It's kind of going to be meaty. Lamont Savings and Loan pays 3% compounded semi-annually on savings accounts. Alan Dean deposited $13.50 for 3 years. He made no other deposits or withdrawals. How much did he earn? So, how many interest periods? This is probably going to be the trickiest because semi-annually isn't, that's 2 periods. All right, it's bouncing off the page. There we go. So that's 2 periods, and then because it makes 3% divided by the 2, it's 1.5%. So the total number of interest periods during the investment, so it's 3 years times 2. So it's going to compound 6 times. So I go from 1.5% down to 6. So 1.5% down to 6, 1.09344. So 1350 times 1.09344 is 1476.14. And then in totality, subtract these two for 126.14. Reliance Bank pays 2.5% compounded semi-annually. So once again, we have 2 periods. He deposited $2,100 in his savings account for 3.5 years. There's that 3.5. No other deposits or withdrawals. How much interest did his money earn? So I have 2.5% compounded semi-annually, so 1.25%. Each compounding period. So 2 times 3.5. So that's probably there's 2 of these. So 2 times 3.5 is going to be, that's another one you could probably do in your head, but I'm just showing you, 7. Let's say you did 3.5. A lot of you are still asking me how to do this on your calculator. The only way to do a fraction on your calculator is with a parentheses. So if you're doing parentheses 3 plus parentheses 1 divided by 2. That's how you represent 3.5. But then you've got to double close that times 2. So you still get 7. But you have to use your parentheses correctly. So this is 7 compoundings at 1.25%. Go all the way down to 7 compoundings. So that is going to be 1.09085. 1.09085. 1.09085. So make sure you got all those places. So clear. 1.09085 times 2100 gives me 2290.79. Then I'm going to subtract. I'm just kind of being lazy right there. So 2290.79. I'm just subtracting the original 2100. So this made 190.79. Now, is that a lot? I don't know. If your money's tied up for 2 years, then, it depends. It's all relative, but on $2,000, that's not too bad. I'm sorry, not 2 years, 3.5 years. So that's kind of a long time. So that's why a lot of people use other avenues of deposit. But if you want to play it safe, that's a guarantee. Okay, 5% semi-annually. So hopefully you're getting better. 2 periods is 2.5%. And then the interest is going to stay for 3 years. So 3 times the 2 is going to be, that's 2. 2 times 3 is 6. And then that's the original, 1750. So I'm going to take my 2.5% and go down to 6. 2.5% down to 6. Puts me 1.1597. Okay, 1.1597 to get this grand amount of 2029.48. And then you're going to subtract 2029.48 less 1750, so 279.48. So that's how much Rita's money earned at 5% semi-annually on 1750. Okay, let's see what the last page has in store. I think I'm just going to kind of like let you do it. So Fred deposited $10,000 for 1 year, which pays 4% compounded semi-annually. So hopefully by now we know that that's 2 periods. Wilma deposited $10,000 at Volunteer Co-op Bank, which pays 5.5% compounded semi-annually. So they're both compounded, same investment. One is 5.5%, one is 4%. Okay? So for Fred, let's do Fred first. Fred is 4%, okay, divided by the 2, which is 2%. 2 interest periods per year. Find the total number. So 2, it's only sitting in there for 1 year, so that's 2. The new principal is going to be $10,000. Now, I don't know if we've had one that big, but you're going to go all the way to 2, all right, down to 2. All righty. So you've got your 2% and then your 2. So 1.0404. Okay. So this is going to be $10,404. So his interest earned, I mean, obviously do this one in your noodle, is 404. So I'm going to do Wilma in orange. So she was earning 5.5% divided by the 2, which is 2.75% at 2 interest periods per year. For the length of the investment is 2. So the new principal, so you're going over to 2.75% down to 2. I just don't want to flip the page again. So you've got 10,000 times that 1.05575 for 10,557.50. Subtract, so 557.50. Now obviously Wilma earned more interest. So this is Wilma, this is Fred. These are, what kind of characters are these? These are Flintstone. Meet the Flintstones. Who earned more interest? Wilma. How much more? So they're not asking how much in totality. Be careful on some of these questions. So 557.50 less 404 is 153.50. So 557.50, this is how much more, less 404 is 153.50. Okay, why did Wilma earn more than Fred? Well, hopefully this one is pretty obvious because she had a higher interest rate. Now, I was hoping this question was going to be a little bit more complicated because you could probably figure out, well, if it's both semi-annual and it's the same, different percent, it's going to make more. But sometimes this can get tricky if it's compounded quarterly or if it, if it's the same interest rate but it's compounded at a different rate, that's going to earn more. So you have to be really careful. This is pretty straightforward because of the higher interest rate. Okay, so your homework is 5.6.7, so sorry, day 1. It's going to be as long as this one, so really spend some time on it. And then our next video will be day 2. Alrighty. And that won't be quite as meaty, but we're getting a little tougher. Thanks for watching and learning.